to go now to my man Biswaroop. Where you at, dude? There he is. How you doing, bro?
Yep, doing good. How are you doing?
I'm great. So, you've got a little talk for us, huh? I'm going to share your screen. It's already up and ready, and we're going to kick it off. I'll be back in 10 minutes. Sound
Sure.
good?
Yep,
See you soon.
cool. Hey everyone, I am Biswaroop Bhattacharjee. I'm working as a senior ML engineer at Prem. So and first of all, like thanks a lot for organizing this event, like Dimitrios and the whole team actually. And there has been like some amazing lined up talks which I was listening to just a while back. Even the talk like just back was like very relevant on deploying LLMs in production in general. Now, I will kind of do a similar take, but on the vision side, I would say. But it's not fully similar because it's a little bit different, I guess. But yeah, it's like it was quite relevant. Okay, I guess we can start. So I'll be just talking about vision pipelines in production and kind of how you basically maybe serve and optimize in general. So let's start. Okay, so this is just a quick rundown of the things like I'll discuss. So we'll first look at the problem like we are trying to solve, and then we will just look at the solutioning bit a little bit. So how basically you are going to solve the problem if it's only one of the ways to solve the problem. And next we will like cover some tricks and low hanging fruits which you can target and anyone can actually target for their vision related pipelines, I think, for increasing their performance in serving. And then we'll take things a bit further for on the performance side, we'll discuss onto it. Okay. So here you can see there is an image on the left side. So this is like an objective of or the problem statement in our case, you can imagine. So something like, say we have to do realistic and ethereal planets image generation. So now we have to generate lots of millions of say images, but it should be following few criterias. And like you can see here, like there are like few criterias I've already listed. So there should be like small space at both the sides, and there should be small height space also, and planets should be only coming under this region. And also there should be like few controllable parameters, something like what the color should be of the planet, as the planet in here is like kind of bluish and whitish. But yeah, there can be like lots of other physical attributes like how is the sky, does it have any nebula, or is there any rings in the planets, or how is the atmosphere like. And there's like a last thing which is kind of important here, that we have that all of these images should follow a particular aspect ratio, which is the 21:9 or the ultra wide scale. So yeah, these are the kind of constraints which we will try to tackle, I guess. Okay. uh, so I will just say that fine tuning can be one of the solutions, but why fine tuning, why not just do any other approaches, something like just basic generation with things like with more basically configurability. But it doesn't quite work for our use case. So it's like you can see how the image is generated at the top left. So it's like a plain simple generation, and it's not very consistent with our requirements, and it doesn't give us like really high level of control. uh, but now since we want a good amount of control, then obviously I think what's better than fine tuning, if you can actually collect a small number of data set. And so let's kind of like I guess discuss how you would actually try to solve the fine tuning task here. So something like you can come up with a prompt creation strategy. So you can see that it's a like large text, but it's a ordered set of text. So it's not like any random text. So right now it starts with a color. So it's kind of for this image which you can see here. So it's a deep blue planet, and there can be things like frosted cloudy zones. So the atmosphere comes in the mid part of the prompt. Then there can be things like no moons or like how many moons. And about the sky also we can write something like distant starry dark sky and all. And yeah, so you come up with a prompt creation strategy, and you kind of curate a small high quality data set. So you can use anything for that, like use Photoshop, Midjourney, etc. Like just come up with few number of images, and it should just be good. It should be covering a good variance of the attributes you want to uh, fill in with your prompts. Yeah, so here at the bottom left you can see there like a small snippet of the images, and these are the things. And after that, like you can maybe choose a model based on how GPU poor or like GPU rich you are, so it totally depends. And yeah, I guess let's quickly move to the results bit. But I mean, fine tuning, like while it happens, it's kind of boring. If it, let's assume it went well, and now we have the results. Now, like the key things come up at the time of productionizing things, right? So you can see like the results in here. I'm showing that before fine tuning was like this, but after fine tuning, it was quite aligned with the things we wanted. So these are like just like few example images, how it looks like. So it's kind of the hemispherical shape which we required. And one thing we actually talked about was the aspect ratio, that it should follow 21:9 uh, aspect ratio. But here what the model I've actually used, or like anyone can use, is stable diffusion XL. Now there are like various other vision models, so feel free to go with your own model if you, whatever you want. But actually stable diffusion XL was trained on only specific aspect ratio of images. So it's like it's kind of listed in here, but this is from the stable diffusion XL paper. And yeah, so the closest basically, so if we talk about the aspect ratio, in our case it was 21:9, which comes out to be 2.3 if we see. And the closest aspect ratio which was used for training stable diffusion was 2.4, and it had like height of 1536 and 640. So we will basically use this dimension, which is 1536 is to 640, for generating an image. So that's so that we get the highest quality possible from the model itself. Now just simply tuning a model and generating a final image, I feel, is not enough. We can do much more things. We can improve it from there, like much more. So here comes things like custom upscaling pipelines. So why custom upscaling pipelines? It's basically to fill all the special nitty-gritty details and give it a lot of more quality in general, I would say. Okay, let's look at them, I guess. Cool. So here is like how a small upscaling pipeline looks like. So this is a very creative area, I feel like. So go full like nuts onto it. Like whenever you try to implement your own upscaling pipeline, there are like a lot of ways, and there's like no correct way, I feel currently. We are just everyone still figuring it out. And yeah, currently how it looks like is it just you just take a upscaler model, you upscale it 2x, then resize it back to whatever you wanted the actual size to be, then you pass it through image to image pipeline. Then this image to image pipeline is basically to give it all the details your image was missing. Now then you again upscale it and then resize it back to your requirement. So this is like a kind of pattern you can see happening in here, and in general it works quite well. I'll show you the results on the next slide. And there are actually also a good public community where people have been sharing lots of workflows or pipelines in general. So feel free to like check out comfy workflows. In general they have been doing like quite well in this area. So yeah, that's a shout out. And yeah, here are some like results, how a normal upscaling can make a difference in your images. You can see how much smudged effect this gives. But if you check this image, this is like way more defined with lots of more magma craterings and all. And similarly goes for like the below image. You can see how different the nebula is. This is like a bit smudged, but this is very distinct. So yeah. Mm, okay, so we talked about the quality of the model in general. Now what about the performance? So how basically you can target the performance, latency and throughput mostly of your pipeline in general. Okay, so if you are like fine tuning a model, mostly you are not doing, I guess, full fine tuning. You might be using some kind of parameter efficient techniques. I mean, obviously you can go with full fine tuning also, but depends on you. So if you're using any parameter efficient techniques, then we have LORAs, right? So they're like quite popular right now, and kind of suggest to like always use LORAs. So it helps quite sometimes if you have like LORAs in general to fuse it with the model, so it helps you with the improvement in the latency. Then always try to use torch.compile whenever it's possible, because yeah, compiled CUDA graphs are like amazing here. And try to use like quantized models as much as you can. So I know it's like always not possible to use quantized variants, but yeah, and that gives us like a lot of boost if you see the graph in the right side. And also another shout out to a like very cool repository called Stablefast, and they have been actually handling a lot of things which I just mentioned right now internally. So all you have to do is just use it and be done with it, I guess. But there are a few caveats which you can check, like it works best with Hugging Face's diffusers library if you're using. But yeah, you can actually make it work with others also. And you can obviously go with serving frameworks like Reserve, something I've been using, and I find it like quite useful. So it supports with a lot of things, specifically improving your throughput in general. So helps you with direct out of the box micro batching support, and you can also do like multiple models, multiplexing, and all sort of those things, and lots of other things it supports. And before concluding, we at Prem actually started a grant program, so feel free to like apply for it anywhere if you're working. So there are like a lot of things we are providing, so like free fine-tuning jobs, free ML model deployments, free ML ad hoc support, or any kind of like sort of thing you would like. And you can read more about it obviously in this link. And key takeaways. So finally, circling back, like it doesn't matter if your data set is small, focus on like the quality of data set. When I say quality, it should be both like image and prompt in the case of vision, I guess. Then obviously target for the low hanging fruits, something like which I talked about, and optimizing the overall pipeline performance. And parallelize and batch things like as much as possible, since you're like deploying a whole pipelines and not just single model. There are like lots of opportunities to parallelize and batch, I feel like. So we should be actually targeting them to improve the throughput and latency in general. And yeah, go nuts with like custom upscaling pipelines, because they can really make the difference, which will make your generation stand out, basically what I feel. Thank you. Yeah, that's all I had, I guess.
Biswaroop, my man. All right, dude. Excellent. Thanks
Thank
so
you.
much for that. I just threw the link for the Prem Grant program into the chat. So if anybody wants to do that and get involved, please click on that, apply, all that fun stuff. It is really cool to see, and I love following your journey and seeing what Prem is up to. It seems like you've been doing some amazing work, and I appreciate you sharing it with us, bro.